start with Fourier's law of heat conduction. Fourier's law states that the rate of heat transfer through a material is proportional to the negative gradient in the temperature and to the area, mathematically expressed as Q equals K nabla T, where Q is the heat flux, K is the thermal conductivity of the material, and nabla T is the temperature gradient. Consider a small element in the material. Imagine a small, one-dimensional element, like a thin rod, of length delta x and cross-sectional area A. We'll analyze how heat flows through this element. Apply the conservation of energy. The change in internal energy of the element over a time interval delta t must equal the net heat flow into the element. If U, x, t, represents the temperature at position x and time t, the internal energy change in the element can be represented as delta U equals Cax, del U slash del t, delta t, where C is the specific heat capacity, and rho is the density of the material. Calculate the net heat flow. The net heat flow into the element is the difference in the heat flux at the two ends of the element. Q underscore net equals Q, x, at Q, x plus delta x, at. Using Fourier's law, this becomes Q underscore net equals Ka, del U slash del x, del U slash del x, x plus delta x, delta t. Equating the change in internal energy to net heat flow. Set the change in internal energy equal to the net heat flow. Cax, del U slash del t, delta t equals Ka, del U slash del x, del U slash del x, x plus delta x, delta t. Simplify and rearrange. Cancel out common terms and rearrange to get del U slash del t equals K slash 0, del U slash del x, del U slash del x, x plus delta x, slash delta x. And the limit as delta x 0, the right-hand side becomes the second derivative of U with respect to x, del U slash del t equals alpha, del superscript 2U slash del x superscript 2, where alpha equals K slash 0, is the thermal diffusivity of the material. Result, the heat equation. The final form of the heat equation in one dimension is del U slash del t equals alpha, del superscript 2U slash del x superscript 2. This equation describes how the temperature U, x, t, changes over time and position in the rod.